Spice math. That's right. We add it up, multiply it, man. Spice math. Okay. A couple things we're gonna learn today. Spice math. All right. Take some time, educate yourself. Spice math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hey guys, welcome to another episode of Spice Math. Our topic for today is a continuation of sequence of numbers. Our objectives are for you to be able to identify patterns in sequences of numbers and to determine subsequent terms in a sequence by using the respective patterns. What you need to know before we begin, I want you to remember the definition I gave you for sequence of numbers previously. And a sequence of numbers is a list of numbers that follow a mathematical rule or pattern. Last time, we established the big question. The big question again is, what is the pattern? You have to first of all analyze the terms given in the sequence and identify a particular pattern that governs the subsequent terms. For today, we will look at 4 patterns: triangular numbers, square numbers, cube numbers, and the Fibonacci type sequences. Triangular numbers can be explained by identifying the patterns using dots. For example, the first triangular number is 1. As I go further, I will now add 2 dots. So for every subsequent number, we would add an additional dot. So the first time I add 1, I'm going to add 2 dots. As I continue, I'll add 3 dots, and then 4 dots, etc. So the second triangular number we identify to be 3. And if a check for you is to ensure I have 2 dots on this side, 2 dots on this side, and 2 dots on this side as well. The next triangular number, I'm now going to add 3 dots. So the third triangular number is, how many dots do I have? I have 1, 2, 3, 4, 5, 6 dots. So the third triangular number is 6. We can use a formula to determine triangular numbers. So to find triangular numbers, we use a formula T subscript n is equal to n open parentheses n plus 1 all divided by 2. Now if I wanted to determine what is the second triangular number, and the second triangular number we found it to be 3, I can use the formula to show that the second triangular number is indeed 3 by saying T subscript 2. The reason I have 2 here because I'm trying to find the second triangular number. This would be equal to 2 open parentheses 2 plus 1 close parentheses all divided by 2. Let's work it out. Which is equal to 2 plus 1 gives me 3. 2 times 3 divided by 2. And 2 times 3 gives me 6. 6 divided by 2 is 3. So we found here that the second triangular number is indeed 3. Right? Another pattern that we'll look at today as well would be for square numbers. And square numbers, we are simply multiplying each number by itself. So again, a formula that would denote squared numbers would be equal to n to the power of 2, or n squared. So what is the first squared number? first squared number. So S subscript 1 is equal to 1 squared. And 1 squared means I'm multiplying 1 times itself. And 1 times 1 gives me 1. So we can establish that the first squared number is 1. If I want to determine what is the second squared number, I would substitute where I see n 2 because I'm trying to find the second squared number. So S subscript 2 is equal to 2 squared. And 2 squared means I'm multiplying 2 by itself, which gives me 4. So the second squared number is 4. Let's now try and find the third squared number. The third squared number, again, I'm going to substitute 3 for n. So S subscript 3 is equal to 3 squared. And 3 squared means I'm going to multiply 3 by itself. And that gives me 9. So the third squared number is 9. Are you getting the flow? Now, the third pattern I want us to look at would be cube numbers. Cube numbers, which I would denote as capital C subscript n, is equal to n to the power of 3, or in other words, we say n cubed. And what n cubed means is that I'm going to multiply n by itself 3 times. So if I want to identify what is the first cube number, I'm going to have C subscript 1, and that is equal to 1 cubed. And what 1 cubed means is that I multiply 1 by 1 by 1 3 times. And 1 times 1 times 1 gives me 1. So my first cube number is 1. If I want to find my second cube number, C subscript 2, this is equal to 2 to the power of 3, or what we say 2 cubed. And 2 cubed means that I'm multiplying 2 by itself 3 times. 2 2s are 4, and then 4 times 2 is 8. So my second cube number is 8. And if I continue, let's try the third. The third cube number is C subscript 3, which is equal to 3 cubed. And 3 cubed means I'm multiplying 3 by itself 3 times. 3 3s are 9, and 3 3s are 9, and then 9 by 3 is 27. So my third cube number is 27. Are you getting the hang of that? Now the final pattern that I'm going to look at with you today is it sounds like a little fancy word. This pattern is called the Fibonacci pattern. Now, what happens with the Fibonacci sequence? What we realize, let me show you if we can first of all see a pattern. 1, 1, 2, 3, 5, 8, 13. Now, what happens with the Fibonacci sequence? For me to get a subsequent term, I would have to add the 2 previous terms. So, if I'm beginning here from 1, they give me this term here as 1. Now, to get the next term, I have 2 previous terms here. So, to get the next term, I'm going to add 1 plus 1 gives me 2. That's for this term. And then to get the next term here, I'm going to add the 2 previous terms. So to get 3, I would have to add 1 plus 2. And then to get 5, I'm going to add the 2 previous terms. So to get 5, I'm going to add 2 plus 3. To get 5. Again, as we continue, to get 8, I add 5 plus 3 to get 8. And to get 13, I add 8 plus 5 to get 13. All right? So in order for us to determine subsequent terms, we would have to add the two previous terms in the sequence, for the Fibonacci sequence. Now that we looked at 4 additional patterns, let's try to find the next 2 terms in the following sequences. You give it a try and I'll try it. Now let's compare what you got to what I got. For the first sequence, I realized that my pattern is I had triangle numbers. Now, we could have done it this way. For every term, I'm going to add one more than I previously added. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5, 15, and 15 plus 6 is 21. If I wanted, however, I could have used the formula that I gave you before. This is the first term, the second term, third, fourth, I want to find the fifth and sixth terms. So in using the formula T subscript N 5, for which I'm trying to find the fifth triangle number, is equal to 5 open parentheses 5 plus 1 close parentheses divided by 2. 5 plus 1 gives me 6, and 5 sixes are 30. 30 divided by 2 gives me 15. So my fifth triangle number is 15. My sixth triangle number, as I use the formula, I got it to be 21. The second sequence, in analyzing the terms given, I realize that I now have square numbers. 1 squared gives me 1. 1 times 1 is 1. 2 squared gives me 4. 2 by 2 is 4. 3 squared gives me 9. 3 by 3 is 9. 4 squared gives me 16. 4 by 4 is 16. 5 squared gives me 25. 5 fives are 25. So this term is going to be 6 squared. And 6 by 6 is 36. And the next term is going to be 7 squared. 7 by 7 is 49. For my third sequence, I have 1, 8, and 27. I realize that I now have cube numbers. 1 cube is 1 by 1 by 1, which gives me 1. 2 cube is 2 by 2 by 2, which gives me 8. 3 cube, which is 3 by 3 by 3, gives me 27. So my next term is going to be 4 cube. 4 cube means 4 by 4, which gives me 16, times 4, which would give me 64. The next term here would then be 5 cube. And 5 cube means I'm going to multiply 5 by 5, which gives me 25. And 25 by 5 is 125. For my fourth sequence, I have 1, 1, 2, 3, 5, 8. Now when I looked at this, I realized this resembles the Fibonacci sequence. And the Fibonacci sequence, to get the next term, we add the 2 previous terms. So I go from 1, I have nothing to add 1 to, so I just have 1 here. Now to get the next term, I now going to add the 2 previous terms. 1 plus 1 gives me 2. To get this term, 2 plus 1 gives me 3. To get this term, 3 plus 2 gives me 5. To get 8, I have 3 plus 5 gives me 8. So therefore, to get the next term, I would have to add 5 plus 8 to give me 13. And then to get the final term, I would have to add 8 plus 13, which would give me 21. Did you get that? Very good. Now it's time for you to do it on your own. Give it a try. Let's compare answers. For the first sequence, what did you get? I realized that I know square odd numbers. 1 squared, 3 squared, 5 squared. So therefore, this term would be 7 squared, which is 7 by 7 to get 49. And this term would now be 9 squared. 9 by 9 is 81. For the second sequence, I realize that I'm going to cube odd numbers now. 1 cube is 1 by 1 by 1, which gives me 1. 3 cube, 3 by 3 by 3, which gives me 27. 5 cube, 5 by 5 by 5, 125. So therefore 7 cube, 7 by 7 by 7 is going to give me 343. 9 cube, 9 by 9 by 9 is going to give me 729. For the third sequence, if we realize, for me, as I go along, for me to get this term here, I added 5 plus 9 gives me 14. Adding the 2 previous terms to get the next term. 23, I had to add 9 and 14 to get 23. So therefore, to get the next term, I would now add 14 plus 23, which gives me 37. And to get the final term, I add 23 plus 37, which gives me 60. How do you feel having conquered these questions, knowing that you were able to look them in their eyes and say to them, I got you? Must be a good feeling. Thank you for tuning in to this episode of Spice Math. See you next time.
You won't believe it's just math. Come on. You won't believe it's just math.